Right. Welcome to the 20th lecture. We are studying Class A amplifier, and in this lecture, we will study minimum power rating of a Class A amplifier. For a Class A amplifier, the minimum rating of the transistor that we'll use as an amplifier, we studied that in one of our previous lectures, and that is PDQ, the minimum rating, the minimum power rating of the transistor that we are using as an amplifier is VCEQ, the Q point collector to emitter voltage, the DC voltage, times the Q point DC current. So the product of these two quantities, this voltage and this current, gives us the power that should that gives us the minimum rating of the transistor we should use as an amplifier. So this is what we studied in one of our previous lectures, and in this lecture we'll numerically find the value of PDQ for this given circuit. So let's solve this. So given this circuit, VCC VCC is 24 volts. So everything else is given, even beta is given. So what we are required to do is to find VCE and IC, and once we are done, we'll multiply these two quantities and we'll get the minimum rating of the transistor. So it's a relatively simpler problem. So let's find the first quantity first, VCEQ first, or IC first. Let's see. So starting from the base, we know we'll apply the approximate analysis and we'll find this VB. We know that according to voltage dividers theorem, this VB is R2 over R1 plus R2 times VCC. So R2 is given to be 1K, R1 is 4.7K, R2 is 1K, R1 is 4.7K, VCC is 24 volts. So plugging all these values in gives us VB equal to 3.9 volts. So this is the VB, and we know this is an NPN transistor. So VE is 0.7 lesser. VE is 0.7 lesser than VB. So VE is VB minus 0.7, right? So VE minus 0.7. This is approximately 3.2 volts. So ICQ is approximately the same as IE. IQ and IE are the same, approximately the same. And we can find IE. You know, this V is the voltage drop across this RE1 and RE2, right? So IE can be found. We can find IE by dividing this sum, this VE by the sum of these two resistors, 120 plus 10. So this gives us IE that is equal to, or IC that is equal to 24.8 milliamperes. So this is the ICQ. So we have computed the first quantity first, ICQ, and then VCE. VCE would be to find VCE. First, let's find this VC. We know the VC voltage, the voltage of collector with respect to ground. When we say VC, this means the voltage of collector with respect to ground. When we say VE, this means the voltage of emitter with respect to ground. And when we say VCE, this means the voltage between collector and emitter. So VC is the voltage of collector with respect to ground that we can compute using KVL, VCC minus ICRC. So we know VCC is 24 volts. We know IC. What's IC? This we have just computed, 24.8 milliamperes, and RC 560 ohms. So we know everything to compute VC. So VC comes out to be 13.9 volts, and then we can compute VCE because we know that VAB for any A and B is VA minus VB. So VCE is VC minus VE. VE is 3.2, VC is 13.9. So this is 13.9 minus 3.2. So this is 10.7. VCE is 10.7 volts. So this is the Q point VCE and this is the Q point IC. So now we have computed both unknowns to compute PDQ. The minimum rating of the transistor PDQ. So we are about to compute VCQ, the power rating of the transistor that we have to use as an amplifier for this application. PDQ is VCEQ times ICQ. This is 10.7 volts times ICQ, 24.8 milli. So PDQ comes out to be 265 milliwatt. So this is the minimum value, the minimum power rating of the transistor that we should use. This is the minimum power rating of the BJT we are going to use for this class A amplifier. For this class A power amplifier. So that's all for this lecture, and with this problem we have concluded class A amplifiers, class A power amplifiers, and from the next lecture onwards we will study the other classes of power amplifiers, class B, class AB, etc. Thank you.